Welcome back. In the last video, we wrote some code to download a target dataset, our own custom dataset from the PyTorch Deep Learning data directory. And if you'd like to see how that dataset was made, you can go to PyTorch Deep Learning /extras. And it's going to be in the custom data creation notebook here for 04. So I've got all the code there. All we've done is take data from the Food 101 dataset, which you can download from this website here, or from Torch Vision. So if we go to Torch Vision Food 101, we've got the dataset built into PyTorch there. So I've used that dataset from PyTorch and broken it down from 101 classes to 3 classes so that we can start with a small experiment. So there we go. Get the training data, datasets Food 101, and then I've customized it to be my own style. So if we go back to Colab, we've now got pizza steak sushi, a test folder which will be our testing images, and a train folder which will be our training images. This data is in standard image classification format, but we'll cover that in a second. What we're going to do in this video is kick off section number 2, which is becoming one with the data, which is one of my favorite ways to refer to data preparation and data exploration. So becoming one with the data. And I'd just like to show you one of my favorite quotes from Abraham loss function. So if I had 8 hours to build a machine learning model, I'd spend the first 6 hours preparing my data set. And that's what we're going to do. Abraham loss function sounds like he knows what is going on, but since we've just downloaded some data, let's explore it, hey? And we'll write some code now to walk through each of the directories. How you explore your data will depend on what data you've got. So we've got a fair few different directories here with a fair few different folders within them. So how about we walk through each of these directories and see what's going on. If you have visual data, you probably want to visualize an image. So we're going to do that in a second too. We'll write a little doc string for this helper function. So walks through dir path, returning its contents. Now, just in case you didn't know, Abraham loss function does not exist as far as I know, but I did make up that quote. So we're going to use the os.walk function, os.walk, and we're going to pass it in a dir path. And what does walk do? We can get the doc string here. Directory tree generator. For each directory in the directory tree, rooted at the top, including top itself, but excluding dot and dot dot, yields a 3-tuple, dir path, dir names, and file names. You can step through this in the Python documentation if you'd like, but essentially it's just going to go through our target directory, which in this case will be this one here, and walk through each of these directories, printing out some information about each one. So let's see that in action. This is one of my favorite things to do if we're working with standard image classification format data. So there are length dir names, directories, and let's go len, file names. I say it length, like I've got the G on the end, but it's just len. Images in, let's put in here, dir path. So a little bit confusing if you've never used walk before, but it's so exciting to see all of the information in all of your directories. Oh, we didn't run it. Let's check our function now. Walk through dir, and we're going to pass it in the image path, which is what? Well, it's going to show us. Oh, beautiful. So let's compare what we've got in our printout here. There are 2 directories and 0 images in data pizza steak sushi. So this one here, there's 0 images, but there's 2 directories. Test and train, wonderful. And there are 3 directories in data pizza steak sushi test. Yes, that looks correct. 3 directories, pizza steak sushi. And then we have 0 directories and 19 images in pizza steak sushi /test steak. If we have a look at this. So that means there's 19 testing images for steak. Let's have a look at one of them. There we go. Now, again, these are from the Food 101 dataset, the original Food 101 dataset, which is just a whole bunch of images of food, 100,000 of them. There's some steak there. Wonderful. And we're trying to build a food vision model to recognize what is in each image. Then if we jump down to here, we have 3 directories in the training directory. So we have pizza, steak, sushi, and then we have 75 steak images, 72 sushi images, and 78 pizza. So slightly different, but very much the same numbers. They're not too far off each other. So we've got about 75 or so training images, and we've got about 25 or so testing images per class. Now, these were just randomly selected from the Food 101 dataset, 10% of 3 different classes. So let's keep pushing forward, and we're going to set up our training and test paths. So I just want to show you, we'll just set up this, and then I'll just show you the standard image classification setup. Image path.train, and we're going to go tester. So if you're working on an image classification problem, we want to set this up as test. And then if we print out the trainer and the tester, this is what we're going to be trying to do. We're going to write some code to go, hey, look at this path for our training images, and look at this path for our testing images. And so this is the standard image classification data format, is that you have your overall dataset folder, and then you have a training folder dedicated to all of the training images that you might have, and then you have a testing folder dedicated to all of the testing images that you might have. And you could have a validation data set here as well if you wanted to. But to label each one of these images, the class name is the folder name. So all of the pizza images live in the pizza directory. The same for steak, and the same for sushi. So depending on your problem, your own data format will depend on whatever you're working on. You might have folders of different text files or folders of different audio files. But the premise remains, we're going to be writing code to get our data here into tensors for use with PyTorch. And so where does this come from, this image data classification format? Well, if we go to the Torch Vision datasets documentation, as you start to work with more datasets, you'll start to realize that there are standardized ways of storing specific types of data. So if we come down to here, base classes for custom datasets, we'll be working towards using this image folder dataset. But this is a generic data loader where the images are arranged in this way by default. So I've specifically formatted our data to mimic the style that this pre-built data loading function is for. So we've got a root directory here in case of we were classifying dog and cat images. We have root, then we have a dog folder, then we have various images, and the same thing for cat. This would be dog versus cat. But the only difference for us is that we have food images and we have pizza, steak, sushi. If we wanted to use the entire Food 101 dataset, we would have 101 different folders of images here, which is totally possible, but to begin with, we're keeping things small. So let's keep pushing forward. As I said, we are dealing with a computer vision problem. So what's another way to explore our data other than just walking through the directories themselves? Let's visualize an image, hey? But we've done that before with just clicking on the file. How about we write some code to do so? We'll replicate this, but with code. I'll see you in the next video.